And welcome back to the Sony Clock Radio PSU teardown. Let's have a quick look and see if we can find what killed it. Well, I speeded this up as trying to cut through this case with a scalpel just took forever, and I never really got anywhere. As you can see, hours, well, not hours, but quite a time spent probing, dragging, slicing and risking cutting my fingers, and to no avail. I just made a few sort of messy lines around it and it didn't seem to want to come apart. And I thought I might be able to service it, so I didn't want to break it. So we carried on, and eventually we tried a different tack. But even putting a screwdriver in the gap didn't make any difference. So now, without further ado, we all swapped to a different mode of attacking the plastic. Well, I started off cutting through the seams with a scalpel, which took forever, didn't get anywhere. So and I tried, as you can see, levering it. The sun's shining badly, it's all in the picture, and that just graunched it. So then I got out the trusted saw through thin boxes with the very thin tight blade, which is a jeweler's saw. I'm not sure where I don't know where the micrometer's gone, but it's a very thin blade. I use it for cutting silver. But so a bit of jiggery pokery with the saw and the thing, it came off. Don't intend using it again, but what I'd like to do is fix it so I can tell exactly what voltage I need. It's kind of hooked on these little hooks. I'll break it off. Looks like I might have sawn through part of the board. Can't see where though, so I'm not sure at all where that bit came. Oh, there it is. It obviously came from there, so yeah, the saw must have caught it. I just wanted to see what was in it, and it's a very good isolation transformer. That well isolated secondary side, very nice isolation. You know, you got a point there, and these are the nearest points of mains side to the low voltage side, so pretty good clearance all the way, pretty good extra isolation on the enameled wire. So my main fault was that maybe the cable had broken, but we'll bring it in. We got that onto one end, so if we get the connection, it comes down to here. So got a good connection on that one. Good connection on that one. Nothing between them. The cable's not broken, so obviously the fault is in here somewhere. None of the capacitors look or feel damaged, but what about the fuse? There's a fuse here. Fuse is gone. Capacitors on there. Come on, focus. 250 volt T1 amp. I have to look up what the T is, whether that's a fast blow or a slow blow. It's got lots and lots of approval markings on it. So there's the RU for TUV. So you could actually go through all the lookups and look up all the different approvals that are on there. That's a simple thing. Did the fuse go with old age or not? Yeah, it's definitely blown. Tempted to solder a link across it, plug it back in, and at least I should be able to measure the voltage coming out. That will help me plan it, and then maybe we'll do a further investigation onto why this blew. But at least we know the culprit is in here. So once I work out what the voltage on here is, we can look for a supply for the radio. Well, I thought I'd bring the microscope in because I noticed something which I thought was an insulating lead, but we'll put the microscope on and try and get a bit more light. There's the reason the fuse blew. Look at it. It's degutsed itself, puked out. There it goes. And you can just about see in there, it's a 22 microfarad 400 volt cap. So I'm going to have to look around, see what I can find in the way of 400 volt caps, and maybe replace the cap, short out the fuse, just long enough to find out exactly what voltage I need. So there you have it. That's why it died. That capacitor has puked up. So as a certain other channel would say, it's always the capacitor. Well, this time it is. But I won't be using this power supply again, having hacked my way into it and possibly sawn through a few things that shouldn't be sawn through. Yeah, if there's any damage, will it focus to the cables down there where I sawed for it? But it was worth a look. Do we have a look at what the main switcher is? Let's just bring the microscope back in, try and work out which way to go. And either an MIP or M1P202. So that gives us a starting point to look for the switcher. Is that the 9th of 96? Didn't realise I'd had it that long. But we'll start looking in here, which is the salvaged components. Just what I rip off boards before throwing the boards away. We've got some big capacitors. 450 volts, good enough. 68 mic, a bit big, but maybe. Made by Cap Exxon, whoever that is. And then we have this one, 400 volt 82 microfarad by Rubicon. So what I'm going to do now, I think, is I'm going to take that, because all the others I've looked at don't fit. Wrong voltage. I'm going to remove that one, stick that on top, put a link over there, just so that I can power it up and see what the voltage is. So I'm not sure if I'm going to bother replacing that fuse and replacing that and gluing it back together. But we never know. We'll have a look. It is well made, well isolated. So let's put a soldering iron on and think about getting this mucky one out once we've worked out where its leads go. So what do we want? We've got some solder, the crinky old solder sucker, and some tea. Soldering iron hot. Negative that way. They look like the offending legs. Put a dab of solder on. Right, that's fallen off. Ah, look. That leg fell off. Not sure if I really want to touch it, but Oops. I think my pliers are magnetised. It burnt through by the look of it. Anyway, that can go in the bin. So what do we need now? We need to suspend that in the air. So, tin copper wire. This is 24 gauge. Good enough for this. Into the cutters. Give it a tug. Make it nice and straight. It's a bit overkill for what I'm going to do. Around those pliers. Give it a squidge. Oops. Solder it on. No, we're doing another one. We'll waste a bit more wire. Again, normally I put the cutters, you can see it there, back of the cutters, turn it about 90 degrees, give it a pull, makes the wire nice and straight. Give it a roll. A bit too tight. Tweak it over a bit. There's solder on that lead. Now I won't be using these capacitors for anything other than play, because obviously they've been ripped out of boards, which means you don't know how good the seals are in there. You don't know how long they've been run for. I can't remember what they come out of. But for doing this, where I just want to power this up with a capacitor on for a few minutes, then they'll be fine. So I shall sit that like that. Bend them apart a bit. No need for blue tack or anything like that, because my finger underneath will be holding them on. The reason I did the little loop was it gives it some mechanical stress relief from the solder joint getting hot while I'm soldering the leg down here. So that's fine. It's quite good. They've put a little rubber support in there that was to hold the original capacitor. And we will just bodge the fuse. Solder on there. Bit of solder on there. Can't pick up the wire. And just replace the fuse with a wire link. Need a new pair of cutters. There we go. So that's the fuse bypassed. That's a new cap. Negative that way, same as it was before. And I say, the only reason I want to do this is I want to know what voltage the clock was run from. And I don't have anything written down on it that says what it is. It does start to smell a bit capacity now. I've heated the board up. You can smell burnt capacitor. Right, let's bring this in so you can see it. I'll stop recording while I go and find a way of plugging that in. Go back and I'm going to plug it into there. Now, not to worry, because what I'm going to do is I'm going to plug that into the mains, and then while it's running I'm going to pull it out quickly and I'm going to plug it into there. So the electricity coming out of here will go back into there, run around the lead and come back out of here. And while it's doing that, it will be isolated from the mains and I'll be able to touch that without worrying about it. Well, if you think that, you're an idiot. So let's bring the meter in. Somewhere about 20 volts. Now this might make me jump if it goes bang. So, will this be long enough in camera, getting tangled up with leads now, to plug into the mains? Over here. Here we go. Wait for the bang. No bang. And no voltage. That's a bit weird. Take this out. Why no bang and no voltage? Neutral. A neutral connection. Live. You have a live connection. Maybe something else is dead. How did that get from there to there? Don't want to touch it unless there's any voltages across that big capacitor. Is there any voltages across that capacitor? No. Nothing across that capacitor. Let's unplug that. Let's get rid of the extension lead. We don't need that at the moment. Fuse. Wire comes in. Wire comes in, goes into the fuse, across the fuse, round there, up there. We've got some spark. I don't know if you can see them, there's little tiny spikes. You see them? Little tiny spikes on the PCB to encourage, if you get a high voltage, it will encourage the spark across that direction because of the spike. We have well, if we put it on buzz, to one side of the diode, to the other side of the diode function. So which one is that to? Oh, I don't know. I'm looking at the diode thing here, but it's not. It's right in front of me here, doesn't it? That's a coil. That's a it's a noise choke. So we have 0.3 of an ohm across there, open across there. So we fuse has blown. The main suppressor, the noise suppressor, has blown. So this could be a point of no return. What about the diodes? Oh, that one's okay. That one's okay. That one's okay. That one's okay. So the diodes are okay. So what do we do now? I think we just take the filter out, get rid of it, and wire link it out. It will do. Oh look, it's made some snot. If you zoom in a bit, oh my belly, let's zoom in. That's the best it will zoom in. Solder. This is a Loctite X396EN2C 0.7mm leaded solder. As you see, it's a full reel. It's not the best solder in the world. It's a bit stiff, and it's only about 2% flux. I'm finding problems with. I'd like a little bit more flux in it. I seem to have problems finding the solder reel. I've had some solder for years, and I seem to have problems finding solder that flows as nice as it used to. This is good. It doesn't leave much of a mess to clean up. And it is no clean, I think. But like as single-sided board, so give it a wiggle. It breaking through. Yep, that was glued on. So that's obviously popped its clogs. So what I'll do is I'll just replace it with a wire link through the hole. Bit more scrap wire. Don't want to waste it and pull up a new bit, so use that bit, something like that. Right, back to where we started. So, bolts. Getting cold tea, so another slug of my tea. bring in trusty power supply, or extension lead. That on volts. I don't care what polarity is which. So they've got to run long enough for us to see what the volts are. Now, as I've taken more and more links out, put more links in, we might get a bigger bang if that capacitor lets go. So, let's try it. Still nothing. Would expect more than that. So, did any voltage get to that capacitor this time? I don't get too close now because it's powered up. .300 volts. There's only 1 volt on that side. So I'm going to give up at that. More dead than I expected. Just thought I'd give you a quick view of the common mode choke, and you can see that on one side of the winding there is a lot of bubbling up and burn marks where it got hot. You can see on here it's discoloured the tape on that side. It's a quite fine winding. It's probably not much thicker than the winding in the fuse. Well, just a quick little extra. This is a TechCAD drawing of the power supply, and I'll just point out what died. T1, 1 amp fuse, that blew. L1, one of the windings blew. Main cause, the 22 mic 400 volt cap dried out and must have gone short circuit. Due to that, there must have been a spike around this area, and the MIP C2C2 died. And at that point, I gave up. So, I'm tempted, just for the hell of it, to see if I can get an MIP 2C2 from, say, eBay, just to see if changing that cap, changing that IC, I don't know, is it worth it? But I just thought I'd show you the circuit. Well, I just thought I'd show you a quick look at the board at the end. If you made it this far, it's going in the bin. So if you liked what you see, please click the subscribe button, click the notification bell, Bing! Click the like button. See you on the next one. Goodbye for now.